Okay, in this proof we are told to use a direct proof. Let a, b, and c be integers. If a divides b and a divides c, then we want to prove that a divides b plus c. And it tells us to use y equals kx to show that a divides b and a divides c. So first of all, we want to start off with our proof method. So we're using a direct proof. So we're using a direct proof. Then we always want to start off with our domain. So we want to let a, b, and c be integers. And we want to suppose that a divides b and a divides c. So now we can use this y equals kx to show that a divides b and a divides c. So I'm going to say by definition, a divides b implies there exists some integer, we call it k, in the set of integers such that b is equal to ka. And then for a divides c, we'll say by definition, a divides c implies there exists some integer, and we have to use another letter for this one because we can't use k, so we'll say u in the set of integers such that c is equal to a or ua. So now we've stated both of our definitions. So now we can go ahead and say then let's just focus on the b plus c part. So we can say b plus c is equal to, now we can plug in because we know that b is equal to ka, so we plug in ka plus, we know c is equal to ua, so ua. Now I can factor out a because I'm trying to get a new integer so I can prove that this statement right here is true. So I need to factor out an a because this is already, this is an integer, but I want to prove it mathematically. So we need to factor an a. So what we'll be left with is k plus u, and then we notice that k plus u yields a new integer, so we say where k plus u is equal to another integer. We'll call it v in the set of integers. Okay, and then since we know that k plus u is equal to v, we will substitute v in for k plus u, so we're left with av. Then we have proven, so we'll say therefore a divides b, put that in parentheses, b plus c. That's the end of proof, and most people in their proofs will square this. And the reason why I can say this, because this is a new integer. Also, this is a new integer, and if I substitute my values, ka plus ua, will get the same thing. So it proves that this statement is true, and that's the end of the proof.